Hi everyone. In this video I'd like to go over some of the ways that we can synthesize our carboxylic acids. So our first method would be oxidation. We've looked at this previously when we were looking at our alcohols and our aldehydes. So remember, we can start from a primary alcohol such as our propanol here, and we can treat it with an oxidizing agent oxidize to our carboxylic acid. Again, remember, for oxidation of carboxylic acids, it requires a strong oxidizing agent. So this would be something like potassium permanganate or our chromic acid. Or it could be, of course, we could just add our potassium dichromate with a strong acid. So this will allow us to go from any primary alcohol to a carboxylic acid. We can also use a similar process to convert from aldehydes to our carboxylic acids. So again, if we add our strong oxidizing agent, we would convert to our corresponding carboxylic acid. We could have any aldehyde treat it with our strong oxidizing agents, and we convert it to the corresponding carboxylic acid. So oxidation is the first pathway, which we've looked at previously, of course. The second main pathway that we could use is a nucleophilic attack on carbon dioxide. So this approach would use our Grignard reagent. So if we take our Grignard reagent, or of course we can start with our halogen. So we'll start off with our halogen. We could treat it with magnesium and of course our ether, which we use to avoid any water. And this would produce our Grignard reagent, where we now have our very strong nucleophile because of our essentially anionic carbon here. Now, if we react this with carbon dioxide, our Grignard reagent will attack that carbon dioxide, attack that central carbon. We move our electrons out of our double bond away from that central carbon, and this will result in our new bond forming here. We would end up with a negatively charged oxygen that associates with our magnesium. We can then treat it again with acid, and we would protonate our carboxylic acid to get our final carboxylic acid product. So overall, then, this would be 3 steps, starting from our alkyl halide, adding magnesium in our ether. Second step would be carbon dioxide. Third step is adding that acid, which protonates our carboxylic acid. And we convert that into our corresponding carboxylic acid. Our third approach is to use a nitrile to form our carboxylic acid. So our nitriles can be produced using alkyl halides. So if we start out with our alkyl halide, we can treat it in a SN2 reaction with cyanide. So if we bring in our cyanide ion, our cyanide ion is a good nucleophile. We can have a basic SN2 substitution reaction, and we produce what we call our nitrile here with that carbon-nitrogen triple bond. Now our nitrile can actually be hydrated to produce our carboxylic acid. So similar to how our other double or triple bonds can be hydrated, we just add our acid and water, and this would be hydrated to produce the corresponding carboxylic acid. So our nitrogen is lost, and the carbon that was within our nitrile becomes that carbon for the carboxylic acid. So overall, we're taking any compound with a halogen. We treat it first with our cyanide. So we add our cyanide ion. Here we have the potassium counterion. And then our second step would be to do the hydration. And we replace our halogen with that carboxylic acid. So overall, we're going from an alkyl halide to that carboxylic acid. So these are our three main pathways to carboxylic acids. We have oxidation, where we can take an alcohol or an aldehyde and convert it to our carboxylic acids. We have our nucleophilic attack on carbon dioxide. This allows us to go from an alkyl halide to our carboxylic acid. And then our third possibility is starting from our alkyl halide and using a nitrile to produce that carboxylic acid.